Thanks everyone for joining us, and thanks for choosing to close out the conference with us. So I'm going to be speaking along with my co-presenter, Matt. So the first part of the talk is going to be me covering the Cloud Development Kit, giving you a little bit of background and some context on custom constructs. And then I'm going to be turning it over to Matt. He'll be talking about his team, Naviance, their journey to the cloud, and how custom constructs helped. So this is actually my second talk at this summit, talking about the CDK. I talked about it at the 2019 summit. I think that was the last talk I gave, so hopefully I'm not too rusty today. I'm a really big fan of the CDK. Prior to adopting CDK, the quickest way for me to create a resource, play around with something, was to go into the console. Now, when I want to experiment with something on AWS, I usually start by creating a CDK app, because it's just easier. So I'm going to start giving a high-level overview of what is the Cloud Development Kit. CDK aims to be a framework that provides high-level abstractions for building cloud infrastructure. Today, we're going to be focusing on the CloudFormation version of CDK, but it also has support for Terraform and Kubernetes. The CDK lets you model your infrastructure using programming languages. These are familiar programming languages. You get to write code instead of writing JavaScript or YAML. You get a lot of great advantages from this. Things like being able to use the tools you're used to. Your IDE has autocomplete and IntelliSense and can easily drop you into the documentation. You can use the package managers you're used to, and you can do things like using testing, using your existing testing framework. All of this is available in not just one language. So the CDK is written in TypeScript, so that gives you TypeScript support. It gives you JavaScript support. But also through foreign language bindings, you have support for .NET, Go, Java, and Python. So your team can use the language that they're most comfortable with. CDK has a number of components. One of them is the core framework, the abstractions that are used to create applications and the guts that wire together the CDK. The second is construct libraries. These are libraries that are modeling your cloud resources. So in CDK, for the most part, a given resource in AWS is going to map to a specific construct. I'll go into a lot more detail on that later. And then, maybe my favorite part of the CDK, although you may catching me call 3 or 4 different things my favorite part, maybe my favorite part of the CDK is the CLI. This CLI lets you, helps you through the entire lifecycle of authoring and deploying an application with the CDK. So now I want to talk a little bit about the development workflow. It starts with creating an application using the CLI. It'll template out all of the configuration files and libraries and folders that you need to get started. Then you're going to go and author your application as you would writing any other piece of code. The next step is going to be transforming your CDK application in Python or Java or JavaScript into resources that can be deployed to AWS. So this process is called synthesis, and you're going to have 2 things that come out of the synthesis process. The first is going to be a CloudFormation template, pretty straightforward there. The second is going to be a set of assets. So this is going to be things like the code for your Lambda function or a Docker image if you're using a container-based deployment method. The CLI will take care of the process. Say for Lambda, it'll pull down all your dependencies, zip it up with your code that you've written, and upload that to S3. And then inject the S3 location into your template. So you don't have to have a break in your workflow to manage these assets. It really helps with developer productivity. The next step is actually going to create a diff. So comparing the resources you have deployed to the resources that you're modeling in your app right now. This is where being built on top of CloudFormation really comes in handy. CloudFormation has the ability to generate a change set, so comparing what exists today with what you are saying you want your resources to be, and it'll highlight anything that's going to be created, deleted, or updated. It's really handy to be able to catch, hey, I didn't mean to delete my database in this change. I'm going to go back and refactor. After you get through the diff process, CDK will hand over your application to be deployed by CloudFormation. So we're now 7 minutes into a talk about CDK constructs, but I haven't really talked much about constructs. So I want to take you through, constructs are the units that you're modeling your cloud infrastructure in. There are 3 different levels of constructs that CDK works with. The first are the level 1 constructs. These are automatically generated from the CloudFormation resource specifications. So as AWS service teams launch new services, launch new features, that'll be reflected in the CloudFormation resources that they vend. And there's a specification file that lists all of the CloudFormation resources. About once a week, the CDK team goes through and ingests that resource specification and auto-generates these level 1 constructs. What this means is that anything you can do in CloudFormation is accessible to you in the Cloud Developer Kit. So you don't have to wait for some update process to happen. The next level of constructs is the level 2 constructs. These are being authored by AWS teams to give you a more native, a more natural view of what the resource you're working with is. So they include a lot of convenience methods to make it efficient to work with a particular resource. So taking a step back, looking at, say, an S3 bucket, for example. The S3 L2 construct has methods that help you easily set up encryption at rest, and will do things like automatically generating a KMS key if you don't specify one to be used. They'll also do things like helping you generate policies, giving you nice convenience methods for authoring them. So it really helps you think about your intent rather than the specifics of a particular service's API or CloudFormation resource. The final level, the L3 constructs, are purpose-built, opinionated abstractions that are really focused on units of your application rather than specific AWS services. And I'll talk a little bit more about the benefits of these higher level constructs. The first is it's giving you larger units of abstraction to work with. So I like to talk about AWS services in terms of Lego building blocks. We give you lots of pieces. And to build an application, often you have to assemble multiple pieces together. I have an example here of a simple serverless API endpoint that you could create. To do that, you'd take a API gateway, a Lambda function, some CloudWatch logs group, as well as some roles to tie all of that together. You can bundle that into a single construct, and using that construct is just a matter of a few lines of code. So if you're sitting here in a talk about the CDK at an AWS summit, there's a good chance you have a fair amount of expertise in AWS. But that probably isn't the case for everyone at your organization. Having these larger building blocks that teams can work with really helps accelerate the development process. The second big advantage is composability. So in this example that I just showed you, let's pretend you now want to have your Lambda function read data out of an S3 bucket. I've seen lots of customers who have developed internal CloudFormation template libraries that describe how to build units of cloud infrastructure like this. But when you go with the pre-written template approach, when you have new requirements, it often means you have to go back to the drawing board to create a new template for this use case. With CDK, you're able to easily compose together different constructs. So in this example, to add an S3 bucket, I just have to instantiate an instance of the S3 bucket construct, and then call the grant read method. And I have all I need to have the IAM policies wired together appropriately. So that takes me to the next benefit of the CDK opinionated constructs. They give you an opportunity to encapsulate well-architected best practices into the infrastructure that you're providing to your larger team. One really big benefit here is good defaults. So you can make sure that the constructs you're vending are using something as simple as the most up-to-date instance types. Or it could be that you're capturing defaults that make sense within the context of your organization. Maybe you have a policy that says S3 buckets always have to be encrypted with their own KMS key using a customer-managed KMS key. You could build that into the constructs that you're vending within your organization. Another big benefit is they give you a point to wire together a whole bunch of AWS services in a way that the consumer doesn't have to worry about each individual service. So in my previous example, the roles that are necessary to make the serverless API gateway work can be included within the construct. You can also imagine doing things like including alarms, including monitoring, putting together a dashboard that captures all of the metrics from your application. And finally, another one of the really important features of the CDK is it makes it a lot easier to implement least privilege. So making sure that your IAM policies aren't overly permissive, it's not easy to accomplish that. Writing IAM policies, going through the loop of developing, deploying, realizing you're missing something, and repeating is something I've certainly spent many, many hours doing. The CDK has those nice convenience methods that let you express your intent, and it'll generate least privilege policies from there. So you can look and see this policy on the screen. It's specifying exactly the methods that need to be granted, and it's also including the specific resources, so the S3 bucket that I want my Lambda function to be able to read from. The final benefit I want to highlight is looking at the testability of constructs. So testing infrastructure as code is a topic that comes up fairly frequently when I talk to customers. And there isn't always great ways to do this. You can deploy your application and look and see what got deployed. You can do some static analysis. But with CDK, you also have the ability to make fine-grained assertions about the state of an application that you're putting together. So you can build unit tests. You're also able to take snapshots, so go through the synthesis process, capture the CloudFormation template that's generated, and then as you go through and make changes to your application, you can compare the snapshot version with the current state of your application, so you can catch any accidental regressions, any changes you didn't mean to make. So now, I want to talk a little bit about where you can find constructs, where we see customers sourcing them from. One option is open source constructs. So there are lots of common and not so common patterns available on the internet. You can find them on GitHub or other repositories. We actually have a site, constructs.dev, the construct hub, that you can search to find over 1,000 CDK constructs that are available today. So it's a great resource to check out as you're starting to adopt CDK and using it more and more in your day-to-day work. One of the things you can find on Construct Hub is actually a set of AWS solution constructs that are created by a team of solution architects here at AWS. These capture common patterns that we see customers building. Actually, the serverless API that I was talking about earlier is from that Construct Hub. From the AWS solution constructs. Another common source is constructs that are built internal to an organization. So you can take constructs, it could be that you have an uncommon application pattern that you're building. Or it could be that your organization has specific policies that they want to implement in their infrastructure as code, or just dealing with specific peculiarities of your environment. Internal constructs are a great solution for this. Commonly, what we see customers do is have a central team with deep expertise in AWS build the initial version of these constructs. It could be a CC Cloud Center of Excellence team. It could be the infrastructure team. So build these constructs and publish them to an internal artifact repository. And then teams from around the organization can consume these constructs from the artifact repository and contribute changes back. Because you're able to leverage the traditional software development processes, it makes it a lot easier than just trying to transfer knowledge when one team develops a best practice or does something innovative. Encapsulating that in a construct and sharing it with the organization is a great way to help everyone benefit from these improvements. So now I'm going to turn it over to Matt, and he's going to talk about how he's worked with constructs and leverage them in AWS.
Thanks, Ryan. Hey, everyone. So I'm Matt Morgan. I'm a Senior Director of Software Engineering with PowerSchool. I work on a product called Naviance, and I've worked on that product for about 5.5 years. All told, I have about 24 years in ed tech. I'm also a co-author of a book called The TypeScript Workshop. You'll hear a lot more about TypeScript later in my talk. I have written a lot of blog posts. My website will be up on the screen later on, but it is mattmorgan.cloud if you want to check that out. And I'm in the AWS Community Builder Program. If you don't know the AWS Community Builder Program, first of all, hello community builders if you're watching. But if you don't know about this program, this is a program you can apply to be a part of. And you should check it out because it's pretty amazing. So I'm going to be talking about Naviance mostly, but the journey that I'm going to be describing begins before Naviance became part of PowerSchool. A lot of times when an acquisition happens, that marks the end of journeys. But in this case, when Naviance joined PowerSchool, we found lots of new like-minded individuals there who have only helped us to reach further into the cloud and develop the ideas that we wanted to follow through with. A little more about PowerSchool on the slide. PowerSchool has a lot of different products under a big umbrella. There are a lot of different technologies in use. I don't even know what they all are, to be honest with you. But we're all kind of looking together on the same journey of how do we increase the operability of our systems, how do we build faster, how do we build better, how do we create common concerns in the cloud and build a better overall platform. All right, I'm going to zoom back out and focus just on Naviance for the rest of the talk. So Naviance is not a cloud native. That's something that I think is a little bit important here because Naviance is about 20 years old as a software platform, a little bit more than that actually. And of course 20 years ago nobody was talking about cloud and there wasn't a public cloud back then. So the journey of Naviance has been largely one that was in data centers and had a lot of the traditional nuts and bolts of operating servers and those kinds of things. When I joined Naviance back in 2016, we were gearing up to do a migration into the cloud. And that migration was what is often called a lift and shift migration, which means that you don't re-architect your application, you just put it up into the cloud. So we went from servers in a data center that ran MySQL and PHP and Apache and things like that. We went on to EC2, ALB, but we did do a couple of things to improve the services that we were consuming. For example, we put our database on Aurora, which let us take advantage of replication and redundancy that Aurora has baked into it. We also stopped using network file shares and instead started storing files on S3, which was a big improvement over the way that we'd been doing things before. And I think that those changes, even though this was a lift and shift migration, which sometimes is something that one is advised not to do, I think it set us up for future success in terms of the changes that we would implement on the platform later. Okay, so now we're in the cloud. What do we do? It wasn't just about putting this application into the cloud and then we're just going to operate it there. We have new capabilities to build. We have a product team with lots of big ideas about features that they want our customers to be able to take advantage of. We also had to recognize that some of the modules that we'd been building over the years, they weren't quite meeting our needs anymore. And we also had to recognize that a full-scale modernization, rewrite every line of code, just wasn't going to be in the cards for us. We had to keep this application running and operational, and so we decided that we would incrementally replace modules with newer technology stacks. I'll get into that a little bit later. We also had to have a better developer experience. We had to engage with our developers, make them be able to make the changes that we were asking for them to make in more efficient ways, and to understand the stack that we were building and to be able to operate it better. And of course, all the other things that you get out of the cloud, the scalability, reliability, observability being quite a big one, no matter what tech stack you're working in. So we started using micro front ends, and and domain services. This is a pattern that I think is an emergent pattern. You start to see more and more of this, which basically means that we have an application that to the consumer seems like a cohesive application. But what we're really doing is we're building lots of micro applications. We're building distinct front ends, distinct services. Users move through them with SSO, and there are common services that tie it all together. This allows an engineering team to be able to build the entire stack, top to bottom, ship it into production without having to coordinate with other teams, without having to be slowed down in their innovative process. Okay, so that was a big one. We started doing that on container-based systems originally. That's where we were, and we weren't yet using the CDK, and we weren't going as fast as we wanted to yet. Another huge one for us on Naviance is data integrations. Data integrations are a really, really big deal for us. We interchange data with a lot of our customers. We have lots of third-party integrations, and since coming to PowerSchool, it's been a priority for us to start integrating with other PowerSchool products in order to provide a more cohesive experience for our customers. So data integrations, the way we used to think about doing data integrations is basically a cron running on EC2. So there's an EC2 instance that sits there with a cron task on it, and every once in a while it's going to say, okay, I do my work now. It's going to maybe pull in a CSV file, it's going to parse the file, it's going to search it for errors, and then it's going to write something into a database. This process was not scaling well for us. These jobs were hard to observe. They failed frequently. They were difficult to maintain, difficult to change, and so we had to find something better for that. Around this time, we kind of came into serverless, and the way that we came into serverless is not the way I think a lot of teams or a lot of developers do by thinking about Lambda and thinking about serverless compute. For us, step functions was the game changer. Step functions, by the way, is my favorite AWS service. But step functions, we realized that by orchestrating our iteration patterns, which we have many, with step functions, we were able to observe them better, we were able to make them more repeatable, we were able to make them easier for development teams to be able to go and build new ones, to fix the ones that we have, and so that worked out very well for us. Of course, going into step functions, we started using Lambda right away. Building with those stacks, we started to realize that our container-based services, we didn't so much need them anymore because now we attach we attach an API gateway to one of those Lambda functions, and now that's our service. And from there, we started thinking about DynamoDB, some of the other things. Okay, so this is great stuff. These are really, really good technologies. They're really, really, really powerful. The problem is, how do you take this team of up to 100 developers who have been working on container services and maybe like a React UI or something like that, and make them proficient with all these technologies, API gateway, Lambda, step functions, DynamoDB, EventBridge. How do we do that? And so this is where we come to building a framework. And the CDK custom constructs, which I haven't even mentioned yet, they're going to be an important part of this. Because we had to put together a framework for learning and a framework for how do we transition this team of app dev into cloud engineers. And the CDK was a critical part of that. So there's more than one way to do this, of course. We had prior experience with CloudFormation and Terraform, and I'm not knocking those technologies. But what I am saying is that our dev teams did not connect with those technologies. We had a couple of years of runway where we were actively using Terraform in production, where it was on GitHub. Any developer could go and read it, could go and submit pull requests against it, and that rarely ever happened. So these technologies weren't working for us, and then the CDK arrived on the scene. And I was immediately very excited about this. So back in 2019 was when I first became aware of it, and I went to reInvent that year, and I became a fanatic overnight. But it was great for us because we're already using TypeScript, because we understand the object-oriented patterns that it implements. The sensible defaults, which Ryan already mentioned, are just a wonderful thing for developers who are struggling to learn these technologies, to say that if you say new table, you'll get some of the defaults that we expect out of that construct, and you don't have to individually set every property that you could imagine on it. And then, of course, the convenience methods, and Ryan mentioned least privilege. The overall story here about the CDK is that it's meeting developers where they are. And I know that for a fact because I spent the better part of my career as a developer, and I immediately connected with this, and I've seen that over and over again with our teams. Okay, so we've decided to build on native services. We've decided to use the CDK, but we're not ready yet. Because there's more that we have to do in order to scale this to our teams and be successful with it. And so part of this is to build the cloud skills, to understand these services, because you can't just write TypeScript code and expect that to be enough. You have to actually know what resources are going to be created and how to operate them and what the limitations of them are and everything like that. So we started focusing on those. We sort of narrowed the list of more than 200 services to the ones that were really relevant for us. And we started creating a narrative just internally about how do we think about these services. So like IAM, I'm a huge fan of IAM. I know that people get frustrated with it, but I mean, if you just think, I have this application made up of a bunch of native services. If you don't have IAM, that means that in every single service you have to generate a secret, and then you have to store that on every other service in order to be able to call the first service. And that just wouldn't be a scalable approach. With IAM, you can create limited roles that allow these things to talk to each other and nothing else. And that's amazing. That is such a good feature in order to have in your application. I could go through all these other ones. I think we're going to run out of time, and I do want to talk about the constructs that we actually went and built. But before we get to that, Another big part of our learning journey was that we had to bring teams together because we have multiple engineering teams with multiple initiatives and multiple responsibilities, and they needed to have a place where they could communicate and share ideas, demo things, decide, hey, we need an answer to this thing. Like, here's, everyone, all these different teams have this same question, and no one has provided an answer, so let's form a working group and go and solve that problem and bring it back to the larger group so that that can be shared out. Another big part of our journey was to put together a reference implementation. The one we have right now, I think, is a little bit stale, but we're working on that. The key here is, welcome to the team, welcome to Naviance. While you're onboarding, you can build and deploy this application in your own namespaced sandbox within 5 minutes. You can do that immediately, and then you can start interacting with those services, and you can start seeing, how did we implement this? And this gets into the custom constructs just a little bit here, because you'd be able to see those, you'd be able to interact with those, and then you could start to mutate that, to start to build it, make it your own, and understand these things a little bit better. Get hands-on with it right away, and see how do we build applications. Another thing I think is really important here, I sort of mentioned this a little bit before, talking about patterns and also TypeScript, but finding touchstones where people, we're hiring people who have real skills that are relevant to us, that really understand app dev, but maybe don't understand cloud so much. There's so much in cloud there's so much that you bring to cloud that's still relevant. So like if you're a React developer, yeah, we still need that. If you know REST really well, that's very, very relevant. Ryan mentioned test frameworks, which are basically the same, and there's so many other things here. So being able to identify those touchstones, make sure that someone, even as they're learning something new, can bring their existing expertise to that. Okay, and I alluded to this slightly before. We're about to get to the construct libraries, but developers having a place where they can go and experiment. So it's not theoretical. You're actually deploying things into a controlled environment, not a production environment, of course, but into an environment where you can make changes and you can observe things. You can see it in the console. You can see whatever observability tools you have. You can use those there as well. So this was really critical for us too. I know that a lot of organizations have gone to single developer sandbox accounts. We didn't do that. We have shared sandbox accounts and some shared development accounts, which we have a distinction there. I don't know if it's important, but that's worked out well for us. I mean, it has allowed us to share some things and to be able to say, well, I'm just, I saw what you did there, and mine's a little bit different, so let's talk about that, and have that kind of collaboration. So the construct library, let's talk about the approach that we took to the construct library, and then I'm going to show you some paraphrased code, if you will, that's actually taken from our construct library. So the construct library, just having one when you have multiple teams writing CDK applications, separate stacks, separate applications, quite often deployed to separate accounts. It's a best practice to start a construct library. It makes a lot of sense. And we had done this before. So we didn't do this before with our cloud technologies, but we were doing Node.js services prior to this. And we had realized that there were some common concerns among many of those services that we were building and deploying. And by putting those into a shared library, we were able to accelerate that effort. So this was the second time of us that we were going through this kind of experience of having a shared library, and so we knew that this was a smart thing for us to do. Oh, okay. Okay, so what are we thinking about with the construct library? What do we want to get out of it? So to start off, if we don't have something like this, if we're building 20 different applications or 20 different stacks, what choice do developers have other than to go into a more mature application and copy code out of it into into the application that they're making? And they will, and they probably should, but I think we know that there's a downside to that, which means that you start to have drift between different, somebody realizes there was a problem in that application, fixes it there, but it doesn't make it into the application that it got copied into. We're also able to bake some best practices into the construct library, and we're able to evolve those. So as we understand these technologies better and learn more, we can release new versions of the library, and then consumers can just do a version bump and get access to that. Ryan mentioned a little bit about compliance here. I think, so the CDK is client side, right? It builds either on your workstation or on a build server or something like that. It's not actually a compliance tool that prevents you from doing something you shouldn't do, but the whole shift left idea here, it's perfect for that because it lets you easily write compliant code, making the right thing to do the easiest thing to do. And then by having constructs and custom constructs, we can just build common patterns faster. We can quick start an application, get it moving, and very soon, instead of focusing on the boilerplate, we're building the application, building the custom features that need to go into it. So to do this, we had to figure out how we're going to publish our library. Like I said, we had prior experience to that, but I just wanted to mention this, so we already had an internal NPM registry that we were using for this. We already had a way that we thought about versioning. We already had a way for publishing an alpha version, for example, which I think is also important here, because in order to consume a construct and deploy it somewhere, you sort of have to publish it in the first place. But if you publish something that's still in an experimental state, you could have some problems related to that. We also put unit tests and quality checks and a full build pipeline behind this thing. So it's not just something that gets launched from a developer workstation. This is treated as the same as any other production application. So there's a little bit of a chicken and egg thing, I think, for some companies, and it definitely was for us, when it comes to thinking about this kind of tool, because do you need to have a platform team in order to start building these kinds of platform tools? Well, we didn't. We didn't have a platform team. Instead, we had a team that was starting working on a CDK application, and we realized in that team that we needed this construct library, and that would help us grow and develop in the right direction. So we created the library just as part of our normal product work for that team, and we made it open for contributions. And we were able to basically parlay that success and build on it, and eventually now we do have a developer acceleration team that is solely about maintaining these kinds of things. One last consideration here when it comes to a construct library. So I actually received the advice that we should use JSII, which is the technology that allows the CDK to publish into multiple languages. We should use that in our construct library in order to be able to have constructs that are also in Java or C# or any of the other languages that are supported by the CDK. We ultimately decided not to do that because we were primarily a TypeScript shop anyway. So I just felt like I would mention this too, because I think that was well-intentioned and possibly good advice, but it wasn't right for us. And so when you think about your inner source strategy, you need to think about that you don't need to necessarily take advice that is generally good advice. You have to think about whether or not that's a good fit for your team as well. Okay, so let's go into the actual constructs. Like I said, these are paraphrase code. This isn't real code, but I wanted to show you some examples of code of constructs that we wrote and published into our internal library. All right, so the first one here is, what we're doing here is we're extending stack, which I don't actually see this very often in the wild. We're extending one of the core building blocks of a CDK application, which is the stack, which correlates to a CloudFormation stack. In this case, this made a lot of sense for us because we had some common concerns that we wanted to be able to have developers be able to take advantage of. So for example, we don't have VPCs in all of our stacks, but in this case, if we wanted to add VPC configuration to a stack, we want to do that in a uniform and custom way, or uniform way across our different applications. The same with EventBridge. We decided on an EventBridge strategy to communicate between different bounded contexts. And we wanted to have a common way for these different bounded contexts to be able to implement EventBridge into their core constructs. And so this is just a couple of examples that go into our core stack, and any developer that is starting a new project based on this stack will be able to implement these things easily. All right, another one that we worked on really early on, and I think that this one is maybe just a little bit of a yak shaving exercise. I think this is the kind of construct that I think one comes up with early in the journey. It's okay, but this construct, I think we've added to it, and we have some more useful things here. What we observed early on is that we were creating and destroying stacks very, very frequently because we were just in this, learning. And so one thing to know about Lambda is that the Lambda, when a Lambda function is invoked, it will automatically create a CloudWatch log group and store the logs there. If you delete that Lambda function later, the CloudWatch group will remain. And if you do this a lot, you'll end up with a whole lot of CloudWatch groups. Now, the CDK does have built-in support for adding log retention, so you can say, I want to only retain my logs for 1 day or something like that. And you're fine. The logs will all be deleted, and you won't have to pay for them, but you will end up with a lot of log groups sitting there, and we thought that was unsightly. So what we decided to do was that we would explicitly create our log groups as part of an L3 construct, and that way, if we deleted that L3 construct, we would also delete the log group. All right, so another one is, this one's probably a lot more ambitious. We created our own REST API construct for API Gateway. And what we really wanted to do here, the goal here was that we decided that we liked OpenAPI or Swagger, and that we wanted to be able to host docs of APIs so that developers could easily understand them. We wanted to generate them. So there's a couple of different options. There's a lot of different ways to go here. One way to go is that you can write your OpenAPI spec, and then you can actually have API Gateway ingest that. We decided that we wanted to go the other way and get our OpenAPI spec out of API Gateway. Now, you can do that in the AWS console, but you can't do that from the CDK code, which is what we wanted to do. And we also wanted to create models in our API Gateway using TypeScript interfaces. So we put all these things together. Like I said, I felt like this was really ambitious. I wasn't sure that this was going to work, but now it's working fine in many stacks in production. We use this third-party library called TS-JSON Schema Generator in order to take a TypeScript interface and then turn it into that on the right. So when we build the stack, it will automatically create the documentation. There's obviously a lot of stuff here that's not on the slide, but I thought it was pretty cool, and it's working out pretty well for us. All right, another one. This was a really big one that we needed to do early on. So we decided that using API Gateway was great, but we wanted to put AWS WAF in front of it. Unfortunately, the CDK does not have any L2 AWS WAF constructs, so we wrote our own. This is a construct that you can implement to put AWS WAF in front of your API Gateway, also in front of CloudWatch, CloudFront. I believe that we support that as well. And if we didn't have a construct like this, developers would still be able to implement API or AWS WAF But it's a lot of extra work, writing all the L1 constructs over and over every single time. So by providing our own L3 construct, we were able to make that available to our teams. So here's another one. We don't actually use New Relic universally across our stacks, but we did decide to use it on some of our stacks, and and there's actually a few steps that are involved in terms of adding the New Relic Lambda layer and pulling the secret out of Secrets Manager. We decided that we would just wrap all that up in an aspect. So you say, all right, I have some Lambda functions. I want to instrument them with New Relic. All you have to do is apply this aspect to it, and the rest is all done. Of course, you do have to have a secret in Secrets Manager. Your New Relic account ID probably has to mean something, but it saves a lot of toil and boilerplate code, and then the developer can go and focus on the things that really matter to us. We also use the CDK for observability. We started off using a library called CDK Watchful, which is a pretty cool library. We eventually decided that CDK Watchful was doing this basically, and we decided that we could get a little bit farther just doing our own. So we have our own constructs that can create alarms and that can create dashboards and things like that, and so that works out pretty well for us too. These are all L2 constructs, so you could include them in a stack like this. It's a lot easier if they just get rolled up in a neat way, and then we can have our baseline of what are our alarm thresholds, and teams can override those as need be. All right, I have two left. I have a little bit of time. So this was a big one. We got this one out this year. It's basically, so I'm talking about all the cool new things that we're building. We're building them on CDK and things like that. We still have an application that goes back 2 decades, right? And we haven't modernized all of that. So there are parts of Naviance. In order to get the full picture together, we need to deploy things that are not serverless, that are not CDK stacks, or at least not natively. And so what we did, in order to provide a better developer experience for teams that are working on new stacks but need to test their code alongside old stacks, is that we packaged up our entire Naviance as a CDK custom construct, and we give teams the ability to just deploy that into an account. And when they do that, they can provide overrides into that custom construct such that the old Naviance stack will have pointers into the new code that just got deployed. And now you can see the entire cohesive experience of how your new stack vertical will look inside of Naviance. The last one, this one is just a little bit theoretical. We haven't started building this yet, but we've observed that we have some asynchronous and event-based workflows that are repeated across several of our stacks. And sometimes developers struggle with those a little bit because they're complex, and that's okay. But we started looking at those and wondering, can we lift those up a level? Can we take these complex workflows that seem to be repeated multiple times across our stacks and publish those as a construct, which will make it easier for developers to be able to implement those patterns. All right, I'm going to share a few metrics in terms of our construct library. So we've had this construct library for about 2 years. In that time, or at least when I pulled these stats, which was about 2 weeks ago, there were 164 commits to it. So what's that, about 2 or 3 commits a week? So it's not that busy. Consumers of this library don't have to worry about constant change every single day, multiple times a day. Instead, it's mostly stable, and a lot of those commits are building a single feature, and then that feature becomes stable. there have been 12 contributors to the library over about 2 years, which is maybe a small percentage of a team that's had more than 100 developers in this time. But I think that part of that is just that the consumers of this library are having their needs met, their needs met, and so there haven't been a lot of need for other developers to go in and start adding. But but it is open for contributions, and we look for that engagement across the teams. In these 2 years, there's been more than 40 projects that have implemented this. Some of those were proofs of concept, some of those were things that never quite took off, some of those are things that are currently in development, and more than 20 applications have gone to production, which is a number that I'm pretty proud of. All right, so we're getting short on time here, but very quickly, some of the things that we had to overcome along the way. The concept of developers creating IAM roles. This was something that we had to have a lot of discussion about. This was not something that we had been doing prior to this. And so we sort of had to prove that we could do this in a safe way. And we did implement some other tools in order to make sure that we were not exposing ourselves to privilege escalation and things like that. Another thing that we did that was, this was one was a little bit more self-inflicted, was that we have a multi-account strategy, and we did a lot of the CDK bootstrapping manually, which basically meant that when new versions came out, especially with CDK2, we had to go and redo that manually. So that was a little bit of a miss, that treating the CDK bootstrap as part of the infrastructure code is probably the way to go. And then just getting used to CloudFormation. So if you've ever seen this CloudFormation update rollback failed, it's really important. That's annoying to get, especially the first time, especially when you have no idea how to get out of this. What we did, and I think this is a best practice, even if CloudFormation was a little bit gentler about this particular error case, when we deploy a stack, we first deploy to a development environment. If it's successful there, the exact same stack can then be replicated into a QA environment. It's successful there, then and only then can it go to prod. So we don't see this in prod. We do see this in our sandbox and dev environments, and developers have elevated privileges there anyway, so they're much more able to take care of those things. All right, so takeaways. This has helped us not just accelerate our own development, but helped us to accelerate our understanding of cloud technologies. It's helped us to promote best practices across our teams, and it's helped us to innovate. And I think most of all is to build that culture where developers across different teams are thinking about these things, thinking about how do I contribute to these, and how do I collaborate and have these crucial conversations. All right, I'll invite Ryan back to the stage, wrap it up.
Yep, so thanks for joining us. And we have if I can find the right direction on the clicker, we have a few minutes for question and answer. So if you do have questions, there's a mic in the middle of the room, and we also have, if you raise your hand, we can bring around a mobile mic. So are there any questions we can answer? Hold on a second to get the mic.
So the first question was like, whatever the constructs that Matt you talked about, are they in the same library, constructs.dev, or is it separate?
None of our libraries have been, none of our constructs have been open sourced.
Okay, your construct.
So I think one of the things that I'd like to communicate about this is that I think the journey is kind of important here. That doesn't mean that we shouldn't do that. We just haven't. Okay, so I'm sorry I can't share that with you right now. Maybe someday we'll have that conversation. Maybe some folks at PowerSchool will see this and be like, hey, why don't we open source that? And then we can share that.
So my second question was for Ryan. So all the constructs that are there in the constructs library, so can a construct written in one language can be used across the other language? So for example, if the construct written in TypeScript, and if you're using your development in the Python, can that be used cross-platform or not?
Two answers. The generic answer is no, but there's a specific case. If you're writing in TypeScript, then you can use the JSII feature to support other languages. So TypeScript to any of the other languages is supported, but you can't go from, say, Python into the remaining supported languages.
Thank you.
So most of the errors that I run into when I write CDK happens when I try to deploy to CloudFormation. And I was wondering if you can talk about, either you, Matt, or Ryan can talk about good ways to do testing. Because when I write unit tests, it feels like I'm writing CloudFormation or writing infrastructure code, but in CloudFormation a second time, which kind of defeats the purpose. So I was just wondering if you can talk around like how you guys do testing, or if that's how you guys do testing.
So one recommendation I'd have is looking at one of the CloudFormation linting libraries, so CFNlint or CFNNAG, and you can wire that into your DuaSynth and then run those linting libraries over it, and those will flag a lot of the common issues that don't pop up until deploy time. Matt?
Yeah, I'll just add, so we do snapshot testing, which has the advantage of it's really easy to just say, match snapshot. And I think, so basically what it does then is it synths the stack, and then it compares against the synth stack. So, and then you can in a GitHub PR or something like that, you can trace the differences. You can say, look, we changed this IAM role or something like that, and see if it matches what your expectation is. That's part of it. The other thing I think is really important is to have a very short dev cycle. So some people complain about CloudFormation being slow. I mean, based on my history, it's a lot faster than a lot of things that I've worked with, but I would deploy frequently. Like, I've added a new SQS, and I'm going to deploy that right now. Deploy, and that's where that sandbox environment, or being able to deploy your own stack, which is a great feature of these technologies, really helps out. You don't want to just be, well, I write my code, and then I deploy to production and hope it works.
Yeah.
I'm not sure if this is on. Okay. So as far as constructs are concerned, do you have a specific kind of analogy that you would say the unit size of a construct? Like, so for example, when I think of libraries, I would think of, if I'm going to build some kind of generic class or something like that, right? We're dealing at an OO level. Right, so you're just building a library of other classes that you can reuse, versus like something like a NPM module that might have a greater level of capability or functionality. Like when you're building construct libraries, where is your mindset in terms of what that library is going to be comprised of?
So we built one construct library and put everything in it, and I think because we wanted them all to be available, we don't have any, someday we may have a specialized library, and then we would publish that separately. We could have published every single construct separately, but then your package JSON just gets really huge.
Right.
And there's not really a downside, in my opinion, to having them all in one library, because it's not like you're shipping it as runtime production code. Instead, it's something that is used at build time, and then and then it goes as cloud assembly to be deployed. So I don't feel like it's too heavy or too slow or anything like that.
Yeah, and if I could just have one follow-up. The reason I was asking, I was taking pictures, but it's hard to take pictures and concentrate the same way, right? So if I wanted to, say, build an infrastructure or something, and I wanted to repeat that maybe in different environments, if you will, and it's just maybe a little different here or there, right? I may build like constructs, if you will, that do something. It's going to do this, it's going to do that, it's going to do this. Make it more like you're coding in like more of a workflow type of way. Is that how you develop when you're, or something similar to that, or are you really lower level? Kind of the same question, but a little different.
Yeah, I think it's what you're. I mean, so we're thinking about solving a problem.
Yeah.
Right. I mean, that's. I think, you know, it's what's right for your team ultimately.
Mm-hmm.
But I think you're heading the right direction there.
So we're actually at time. I believe we'll have the opportunity to take some questions after the session. I want to thank everyone for coming and also remind you, please fill out the survey. We definitely value the feedback.
Thank you.